Welcome to CSEGuru. In this session, we will discuss the topic how to implement a C program to convert infix expression to postfix expression. Already, we have discussed an algorithm to convert infix to postfix expression, and also we have discussed with 4 examples. Now, we are going to implement a C program to convert infix to postfix expression. So, for that, the algorithm, how to implement the algorithm, we need the knowledge. For the given infix expression, first step, we need to add a closed parenthesis at the end of the infix expression. Then by default, push an open parenthesis onto the stack. And step 3, repeat until each character in the infix notation is scanned. If an open parenthesis is encountered, directly push it onto the stack. If an operand, it may be a character or any digit that comes into the category operand. If an operand is encountered in the sense, add it to the postfix expression. Directly, we can place it in the postfix expression. And if a closed parenthesis is encountered in the sense, repeatedly pop from stack and add it to the postfix expression. Whatever the elements present in the top of the stack, until you encounter the open parenthesis, pop the element one by one and place it in the postfix expression. After doing this, discard this open and closed parenthesis. Suppose if an operator is encountered in the sense, you have to check the top element of the stack whether there is an operator. If an operator present in the top element of the stack, you need to compare the incoming operator with the top element of the stack. If both the operator is having equal precedence or stack operator is having higher precedence in the sense, pop the stack operator and place it in the postfix expression and then push this incoming operator into the stack. If it is a lower precedence in the sense, directly push it onto the stack. So whenever an operator you are encountering, you need to do this comparison. Suppose after scanning all the infix character, if there is any elements present in the stack in the sense, pop it and add it to the postfix expression until stack is empty. If you are implementing all these steps in the sense, finally you will get a resultant postfix expression that is nothing but the infix expression converted into corresponding postfix expression. And this algorithm only we are going to implement as a C program. So here has defined max 100 elements and ST of max. ST represents stack. Stack maximum element is 100 elements you can able to place it. And top is equal to -1 in the sense initially we are considering stack is empty. This is push function, pop function and the conversion of infix to postfix function. Okay. So for this conversion, what is the input, that is the infix expression is required, and the target, that is step by step you will convert the infix expression into postfix expression that will be placed into the target variable. And here enter any infix expression. Any infix expression you can give as an input and accept as a string. Infix expression you need to accept as a string and automatically null character, if it is a string, automatically at the end of the string null character will be added. That represents the end of the input string. And str copy of postfix, it is an empty string. So for the postfix expression, initially you are copying it like an empty string. You are considering it like an empty string. Okay. Then this is the user-defined function infix to postfix. Okay. What is the input infix function you have given, that you have to pass it, and what is this postfix expression, that is an empty string that you have to pass it. Once the function is called, the control will be transferred to the user-defined function infix to postfix conversion. Okay. So here source string will be given and target string will be given. Target string will be considered like an empty string. That is the postfix expression. Okay. And here in this function, the target string is also empty string only. Okay. This is the actual statement where we will scan the input character by character. So here source of I not equal to /0. /0 in the sense it is a null character. So if it reaches the null character, meaning is the string comes to an end. That is the meaning. So we cannot able to scan. Okay. Then condition will fail. Okay. Suppose if source of I not equal to /0, implement the following code. Okay. So here if source of I is equal to open parenthesis, if open parenthesis you have encountered in the sense, what you have to do? You have to push it onto the stack. So whatever the stack data structure you are having, directly push it onto the stack. And then from the source to stack, you have to place the character open parenthesis and then I++. For example, if it is A plus B into C, if this is the input string in the sense, so once you have scanned this open parenthesis, You have pushed on to the stack. Then you have to move to the next character. You need to scan the next input character, right? For that, this increment operator is used. Okay. Then, if source of I is closed parenthesis in the sense, what do you have to do? Suppose input is closed parenthesis in the sense, what is the meaning? Until you reach the open parenthesis, for example, here, A is there in the sense. For example, if A is there in the sense, until you reach the first two open parentheses, whatever the elements present in the stack, pop it and place it in the postfix expression. Okay, that is the rule. Okay, so here, if it is a closed parenthesis and while top not equal to -1, meaning the stack is not empty, that is for that condition checking only, we are using this condition, top not equal to -1 and stack of top not equal to open parenthesis. It should not be open parenthesis. If it reaches open parenthesis, you can cancel this open and closed parenthesis. Okay. Until you reach this open parenthesis, whatever the elements present in the stack st, pop it and place it in the postfix expression. Here the postfix expression is nothing but the variable target. Pop the element one by one and place it in the postfix expression until you encounter the first two open parentheses. Okay. Then increment the j variable. And if top is equal to -1 in the sense, what is the meaning? Stack is empty. Suppose if stack is empty in the sense, it has to print a message incorrect expression. If top is -1 in the sense, then it will exit. No need to check any condition here. Automatically it will exit because there is no character to scan. Okay. So if top is equal to -1, print this message and exit. And then temp is equal to pop of st. This pop of st in the sense, what is the meaning? Open parenthesis will present in the stack. Whenever you are encountering a closed parenthesis, until you encounter the first open parenthesis, pop the element from the stack and place it in the postfix expression. Suppose if you are encountering an open parenthesis, what do you have to do? Pop it. Just to pop it. Don't place it in the postfix expression. Just to pop it. If a digit you are encountering, the source input, whatever you are scanning, you are encountering a digit or alphabet in the sense. What do you have to do? Directly place it in the postfix expression, right? So from the source, directly place it in the target. Target is nothing but the postfix expression. Then increment the j variable as well as I variable. If you are encountering digit or alphabet from the input, that is from the source string, directly place the character or digit in the postfix expression. So if you are encountering a open parenthesis, push it onto the stack. If you are encountering a closed parenthesis, till you encounter the first two open parentheses, whatever the elements present in the top of the stack, pop it and place it in the postfix expression. Okay. And then remove the open parenthesis. Suppose if it is a digit or alphabet, place it in the postfix expression. Now, if it is a operator in the sense, if source of I is plus operator or minus operator or multiplication or division or modulus operator in the sense, what we have to do? We need to compare the incoming operator with the top element of the operator present in the stack. Okay. If it is a higher precedence operator in the stack, pop the element from the stack and place it in the postfix expression and then push the incoming operator into the stack. Suppose if it is a lower precedence operator present in the top of the stack in the sense, push this incoming operator, that is a higher precedence operator, into the stack. Okay. That is the condition. So here, if you are encountering a plus operator or minus operator or division or multiplication or modulus operator in the sense, while top not equal to -1, it should not be empty. Okay. And stack of top not equal to open parenthesis. Stack of top should not be an open parenthesis. If it is an open parenthesis, no need to do any comparison. Directly you can push this operator into the stack. Suppose if it is a higher precedence operator present in the top of the stack in the sense, you need to get the priority of the top of the stack operator and the priority of the incoming operator. Both you have to check it. If the top element of the stack operator is having higher priority compared to the incoming operator in the sense, pop the top element of the stack operator and place it in the postfix expression. If the stack top element operator is a higher precedence operator, pop it and place it in the postfix expression, then increment j variable. Okay, suppose if this condition fails in the sense, what you have to do? Directly push the incoming operator into the stack. From the source, you have to place it in the stack data structure. Meaning is the top element of the stack operator is a lower precedence operator and the incoming operator, that is the source operator, is a higher precedence operator. In that case, you can push it onto the stack. Suppose if this condition is true, in the sense what you have to do, pop the stack operator and place it in the postfix expression. For example, here this is a stack data structure. Suppose here plus operator is there and input operator is star in the sense. In this case, what we have to do, this is a input, okay, this is a incoming operator and this is the stack operator. Top element of the stack, it is a plus operator. The incoming operator is having higher precedence, stack operator is having lower precedence. In this case, push this star into this stack, no problem. You can place the higher precedence operator above the lower precedence operator. Suppose here, if it is a plus operator and in the stack, the operator is multiplication operator. Okay, this input operator is a plus operator and in the stack data structure, it is a multiplication operator. In that case, what we have to do, pop this stack operator and place it in the postfix expression. Okay, now the stack will be empty. Then you have to push this plus operator into the stack. Now here plus operator will be there and the multiplication operator you have popped and placed in the postfix expression. So this is the difference you have to do. If it is a equal precedence operator also, suppose here plus operator is there, here in the stack it is a minus operator, both are having equal precedence in the sense. In that case also, you have to pop it and place it in the postfix expression and then you have to push the incoming operator into the stack. So in the stack, if it is a higher precedence operator or equal precedence operator, in both the cases, you have to pop it and place it in the postfix expression and then you have to push this incoming operator into the stack. Okay, so here equal also we can add the condition. Okay, in both the case, you have to pop the stack operator and place it in the postfix expression. Okay, suppose if the stack operator is lower precedence, incoming operator is higher precedence, push it onto the stack directly, no problem. Okay, and then increment I variable. Okay, so this is all the conditions. Suppose if all these conditions fails in the sense, finally it has to print incorrect element in the expression. That is, in the infix expression, it should be open parenthesis, closed parenthesis, alphabet or digit or any other valid operators only. If at all any other special symbols present in the sense, all these conditions will fail. In that case, it will print a message, incorrect element present in the expression and automatically it will exit. Can you able to understand the implementation of C code? If you understand the algorithm properly, you can able to understand the C code easily. So before go through this video, please refer my previous videos. That is the algorithm to convert infix to postfix expression and also with 4 examples I have discussed. If you understand those steps properly in the sense, this implementation code is very easy. And then here pop function and push function. Pop function if you are considering in the sense, if top was -1 in the sense, meaning stack is empty. In that case, meaning stack is empty, it will display the message and it will exit. Okay, because there is no elements present in the stack, we cannot able to pop any element from the stack. Okay, suppose if this condition fails, meaning is elements present in the stack in the sense, pop the top element of the stack and decrement the top value. Okay, so this is the pop function. And push function if you are considering, here you have to check the overflow condition. Suppose here top is equal to max -1, that is whatever the maximum position you have allocated, all the maximum position values are filled in the sense, you cannot able to push one more element into the stack. That is the meaning. It reached the maximum allocation. So in that case, it will display stack is overflow. Suppose if this condition is false in the sense, that is top is not equal to max -1. In that case, increment the top position, then place the value in stack of top. And one more function is required here to get the priority. So get priority of operator. Whatever the operator present in the infix expression, you need to do a comparison, right? Before converting it into postfix expression. So for that comparison, one more function is required. If the operator is division, multiplication or modulus operator, value you return it as 1. Meaning is, these are all higher priority operators. Suppose if the operator is plus and minus in the sense, return 0. These two are lower priority operators compared to these 3 operators. So most probably here we are going to implement the arithmetic operators only. In the arithmetic operator itself, addition and subtraction is having lower precedence. multiplication, division and modulus is having higher precedence. So for this implementation, you need to get the priority. If the operator is multiplication, division and modulus in the sense, it will return the higher priority value 1. If it is addition and subtraction in the sense, it will return the lower priority value 0. So this is all about how to implement a C program to convert infix to postfix expression. Thank you for watching this video.